Hey guys, welcome back to chapter 4. We're in section 3 now, and we are going to model with quadratic functions. Now, modeling could be two things in my head. It could be a graph, or even better, it could be an equation. Okay, that's my dog. She's eating something, but that's okay. We're just going to let it go. Okay, part 1 today. How do you make a quadratic model? How do you make an equation given 3 points? So that's going to be the first thing we do, 3 points in making an equation. And then part 2, let's go ahead and use that model conceptually. So let's use our equation and our graphs and kind of try to understand these things. Now, part 1, how do you make a quadratic model by hand from 3 points? So we're going to take a look at this basketball player and the shot that he made. So this basketball player threw a basketball, and we're going to try to make it into the hoop using a parabolic path. Example 1, a player throws a basketball toward the hoop. The basketball follows a parabolic path through the points that are shown. So we have 3 points. That's how far over and how far up. How far over and how far up. What is the model of the parabola? In other words, what's the equation? Now, we've done this before. It was from chapter 3, section 5. We called it the 3-column method. So I just kind of typed the 3 columns out here for you. So we know that this is standard form, or I should say we should know that is standard form of a quadratic function. Step 1, we're going to substitute the first point. See that 2, 10? That's going to go in this first column. So when I see, let's see, so it was 2, 10. Every time I see an x and every time I see a y, they got to get replaced. So instead of y equals a times x squared plus b times x plus c, I am going to go ahead and erase my y and put in a 10. I'm going to replace my x with a 2. I will use parentheses because if it was negative, it makes a really big deal. And I'll do the same thing here. I see an x, so I will replace it with 2. Now we're going to go ahead and simplify that equation here. This should look very similar to what we did in chapter 3. Some of you may be wondering, how did you get 4a? That is because 2 squared is 4. And that's how I got 4a. That's the same reason I got 2b, because this is really 4 times a, and this is 2 times b, and then c drops down. Now it's time to get, just like we did in chapter 3, get a variable by itself. I tend to get c by itself. If we get c by itself, we could subtract 4a and subtract 2b. I'm going to have 10 minus 4a minus 2b equals c. So getting a variable by itself, that's one of our Algebra 1 skills. Put a star here because we're going to need that in step 2. Substitute the second point in for x and y. So just like we had y equals, here's our standard form. My hope is that you know this is standard form. We need to substitute our second point in. Well, our second point is up here, and it is 412. So 412 is getting put in, just like we did in step 1. So instead of y, I need a 12. So this is x and y from our second point. A times x squared. Use parentheses, because if you don't and it's negative, you might screw it up. Okay, so we're putting in 12, 4, and 4. And now it's time to kind of get this into standard form, like a linear standard form. So that's 12 equals 16a plus 4b, because 4 squared is 16. Now, notice I'm taking a pause. I'm going to actually replace c, just like I did in chapter 3, section 5. I'm going to replace c with this stuff. So I'm going to grab that. I'm going to put that in for c. There you go. I may as well put a plus sign there. So you have to replace x, y, and then we also had to kind of get c there. Let's put this thing into linear standard form. So what are we going to have? We're going to have our 12. We're going to have our, instead of 16a, I'm going to have 16 minus 4. I'm going to have 12a here, combining my like terms. And what will I have here? Let's take a look with red. That's going to be 4b, and negative 2b is 2b. And then I have that random 10. And I'm going to take this 10 over like this. So I have 2 equals 12a plus 2b. But I really know that kids can't stand, like, or it's really not pretty like that. So I would much rather just have my equals 2 over here, which is a completely legal math move. This is in linear standard form. Remember, we put in x, we put in y, and we put in c from step 1. Now, just like chapter 3, section 5, we have to do that one more time. So we have a third point. Any 3 points will make a parabola. So here we go. We're going to take a look and grab this. And what was our point? 10, 12 was our third point. Okay, so 10, 12. What's my dog eating now? Okay, there we go. We're going to put in, so we have our y, standard form of a quadratic. All right, let's take away the y, make it 12. We don't know a, we know x. We don't know b, but we know x. And then remember what c was? I'm going to have to kind of move this over and shrink it down because I got to be able to fit c. Okay, so remember c was over here. So our ultimate goal is to figure out what a, b, and c are because that's what makes a quadratic function. We got to figure out what a, b, and c are. So we're going to do that in standard form. Okay, combine our like terms. So we're going to have 12 equals, that's actually 100a, and this is 10b, plus 10 minus 4a minus 2b. Let's combine those like terms. So we'll have, that's a kind of a big one there. Oof. So 12 equals, that's going to be 96a, combining our like terms, our Algebra 1 skill there, plus 8b plus 10. Take the 10 to the other side. And, oops, excuse me, I need that to say 2 equals 96a plus 8b. And that is in linear standard form. But you know what? I think I remember in the last, most people like to see that equals 2 over here. And that's completely fine. You're allowed to rewrite it like that. I think it's easier for kids. Okay, so reviewing our steps, we had 3 points. We put point 1 over here and solve for c. Then we put point 2 here and also put in c from step 1. Put point 3 in over here and step 3 from step 1. So we did this back in chapter 3. Hopefully that rings a bell for you. Then we always had this pattern, this flow here. So I'm going to try to stay consistent with that so the steps look the same like they did in chapter 3. And we're going to eliminate our answer from step 2. So this one. And this one. Okay. I'll put that circle back on so it's consistent. I don't know, I have issues. There you go. And now it's time for us to solve for A or B. I'll probably solve for B here. So I'll multiply, since I'm feeling a little lazy, I'll just multiply the top by negative 96 and the bottom by 12. There could probably be an easier thing to multiply by, but I'm just not taking the time to find it. So negative 96 times 12 is, that's really actually quite ugly, isn't it? There's nothing wrong with what I'm doing. It's just kind of the lazy way to do it. Negative 96 times 2. You could have multiplied the top by negative 4, just so you're aware. Equals negative 96 times 2. Now, if this is a skill that you're like, I have no idea what you're doing, Miss Angeli, that's probably an issue that needs to get fixed. Okay, this is elimination back from chapter 3, section 1, or section 2. So I'm distributing the 12. I'm really hoping at this step, this is something that you're used to seeing. Multiplying by these numbers in the front, making sure you have three positives and 1 negative. And then distributing it through. That's what's going on right now. I'm distributing it through. All right, so what's that going to be? That's a positive 96. I'm also doing this without a key, which makes me very nervous, but that's okay. All right, I think I'm okay. I don't think I made any mistakes. Watch, I'm going to be so embarrassed. We all make mistakes. Eliminate those A's, go away. Let's see, what is 1 negative 92 plus 96? That's negative 96b. What's negative 192 plus 24? It's negative 168. Okay, let's see what we get here. 1 we divide by negative 96. Negative 168 divided by negative 96. Good, I think that looks pretty good from what I remember from me doing before. So B ends up actually being 7 over 4. But you know what, since we're using a word problem, and since it's like a pretty decent decimal, I'm going to go ahead and, since I lost that, that's awesome. Good job. Go me. What did I just have? Oh, my belly's growling. 175. There. I'm going to go ahead and leave B like that. So I'm going to circle that. I'm going to put a star by it because we found one answer. And if you remember from chapter 3, when you find one answer, the rest of them get a lot easier. So we're going to plug that in back. We're going to follow my arrowheads. And that's going to go in right here for this B. So we're going to get 12A plus 2 times 1.75 equals 2. And that's going to be 12A plus, let's just double check since I don't have my answer key with me. I don't want to do anything dumb. What do I get? 3.5. I would subtract 3.5. Sorry, I don't know why I wrote equals there. Again, this is solving using our skills from chapter 3. So 2 minus 3.5, negative 1.5, and here's the kicker. Let's see what we get here. I need to divide by 12. Good, I remember that being the answer. Negative 0.125, and I think that's negative 1/8 if I remember my answers. Good. So I know I did that right. Put a star there. We got another answer. And now it's time to get C, okay? So to get C, we go all the way over here. And we carry down that box right above. And then we'll fill in. So for A, we just got, I have it here on my calculator, negative 0.125. That fills in for A. And for B, I better go double. B, we got, I do believe we got 1.75, but it would be really smart if I went over there to check. Oh, that's embarrassing. Excuse me. All right, I just want to make sure that is in fact what we got for B. Yes, it is. All right, grab that calculator back because again, I don't want to have to redo anything. 10 minus 4 times negative 0.125. And what is that? A minus and a 2 with a 1.75. And we end up with 7 for C, which is pretty good. All right, so our steps were very similar from everything that they were in Chapter 3, Section 5, okay? We get our 3 unknowns, and now it's time to actually write the model. Well, remember, this is standard form. Now we fill in A. Pretty certain that was what A was. We fill in B. Better look at it. And we fill in C. And that is the model that they're looking for. So the model consists of finding A, finding B, and finding C, and filling those in. But you had to work for it pretty hard here. Now we're going to use that model, and we're going to see if we can. We're going to use this model right here, and we're going to see if it goes through 12, 10. So that means that every x needs to become a 12. Let's do that. Let's make every x into a 12. And I'm going to grab my calculator. Now, if I get the answer of 10, then yes, it goes perfectly through the hoop. Let's see if we have perfection, okay? Let's see. So negative times 12. Oh, I almost forgot to square it. That would have been so embarrassing. Plus 1.75 times 12. But some of you noticed that, huh? So I get 10. Nice. So in other words, I'm going to write it mathematically because why not, right? F of 12, when I plugged in 12, I got 10. That's essentially what I'm saying. When I plugged in 12, let's look at it. When I plugged in 12, I got an answer of 10. So will it go through the hoop? Absolutely, as we got the point 12 comma 10 when we plugged it in. So it's going to be a perfect swoosh. And it says, how high is the ball when it's 3 feet over? So 3 feet over is the x. So we would do the exact same thing. We would take out our x's and we're going to put in a 3. Take out our x's and put in a 3. Let's do that one more time here. You could put this in your y equals. I guess I'm kind of doing it the slow way, but there's nothing wrong with that. Slow and steady wins the race. Let's see how high up it is when it's at 3. It's at 11.125 feet in the air. And let's see if that makes sense with our graph. 3 would be here, right? And that's like 11. That makes total sense. See it? That would make good sense for what we got of 11.125 feet. All right. So the next problem is going to be done on a calculator, a handheld calculator. In order for me to do that, though, I am going to have to transition to my laptop.